Hello children. In the thermodynamics, in this lecture we will start heat energy, work and internal energy. We can define as heat energy the energy which flow due to the temperature difference between system and surrounding, and that energy is known as heat energy. Now we can define work in thermodynamics. It is like as mechanics. When the energy transfer between system and surrounding, then work is said to be done. Now, we can calculate the work done during expansion of gas. Expansion of gas, let us consider a system containing gas molecule having V1 is initial volume. During expansion, V2 is final volume. Let P is pressure exerted by gas molecule on the piston. These gas molecules are applying the pressure on the piston, so it will move outward. Let we can assume dx is small displacement. Now, according to the relation pressure force upon area, this A is area of the piston. Now we can calculate force, this is pressure into area. For the small displacement, small work will be done, that is dW. So we can write here work is equal to force into displacement. So dW is equal to force, we can write here pressure into area into dx. Now this is area into dx. Now we can say area into length is equal to volume. If the length is small, volume will be small. So we can write here A into dx, this is equal to dV. So we can write here dW, this is equal to P into dV. To calculate the total amount of work done, we can integrate. Now dW is equal to P into dV. Initial volume V1, final volume V2. So W is equal to P. This is, we can write here V2 minus V1. Or for sign convention, during expansion, work is positive. During compression, work is negative. Now we can write internal energy. It is the sum of kinetic energy and potential energy. So we can write here U is equal to summation kinetic energy of all the gas molecule plus summation potential energy of all the gas molecule. If the kinetic energy change, then internal energy also change. If potential energy change, then internal energy also change. So the internal energy of the gas molecule, that depends upon kinetic energy as well as potential energy of the gas molecule. Internal energy of a real gas. In a real gas, the molecule exert force on one another. Force on one another. So they possess potential energy. This potential energy depend upon distance which further depend upon volume. So we can say internal energy is a function of the volume. The real gas in motion also, so they possess kinetic energy, and kinetic energy depend upon temperature. So internal energy is a function of temperature also. If we combine these two, so we can say that internal energy depends upon kinetic as well as potential. Potential depends upon volume and kinetic depends upon temperature. So internal energy is a function of temperature and volume. Internal energy of ideal gas. According to kinetic theory of gases, which gives the model of internal energy of ideal gas. Intermolecular force is zero between the molecules, so potential energy is zero. Now we can say that molecule only has kinetic energy and kinetic energy depend upon temperature. So internal energy is a function of temperature only. So we can say U is F of T.